Hello everyone, welcome to R programming lectures. So let's continue with the matrices in the R programming. So in the previous lecture we have been discussed about what is a matrix and how to create a matrix. And after creation of a matrix, what are the different parameters that you need to pass and how to access the matrix elements that we have been discussed. Now let's continue with the other topic, that is how to add the rows and the columns. Suppose if you want to add a row to the existing matrix, you have to use R bind function. If you want to add a column to the existing matrix, then you have to use the C bind function. So let me execute with an example. For example, let's take matrix 1. So let me clear this console and let me execute matrix 1 again. Yes, this is a matrix 1. So what I want to do is, I want to add the columns to the matrix 1. So matrix 1, you take matrix 1. So I want to add a column, then you have to use a C bind function. So within the C bind function, the first argument that you need to pass the existing matrix. So what is our existing matrix? Matrix 1. So better you take this as matrix 3. Okay. So the existing matrix is matrix 1. For the existing matrix, I need to add the column values. So to add the column values, what you have to, here you see, suppose I want to add one column. One column means two values that you need to give. So two values that you need to give, that's why you have to give within the C function. For example, already apple, guava, banana, cherry is there. Suppose here I need to give orange, and the second value, suppose I want to give kiwi. So this is a way you can create a matrix. Let's print matrix 3. See here. So observe the previous one and this one. Apple, guava, orange, banana, cherry and kiwi. So orange and kiwi is given. Here you see. And the column name is not given. You can give the column name also. After that you can give the column names. So this is a way you can add a column to the existing matrix. For example, I want to add a row to the existing matrix. So then create a matrix 4. So we have to use the R bind function to create a row to the matrix. So the existing matrix, that is matrix 1. So row means, so we have to add two values again. So two values means you have to give a C function. Suppose I give that kiwi and orange or grapes. Suppose here I give grapes, and the second value that I give melon. Just enter this and print the matrix 4 values. See here. So grapes and melon has been added as a third row. By using the R bind function, the row can be added to the existing matrix, and by using the C bind function, the column could be added to the existing matrix. So this is the way you can add the rows and columns. Now we understood that how to add the rows and how to add the columns. So let's remove the rows and columns. How to remove the rows and columns? By using a C function, we can remove the rows and columns. So you have to give hyphen and a C of 1. This is representing the first row, and hyphen C of 1, it is representing the first column. So let's execute the matrix 4. We know the matrix 4, right? So in the matrix 4, suppose I want to remove the first row, C of 1 I am giving. Also I want to remove the first column, first row and first column. What happens if I remove first row means these values will be removed, and first column means apple, banana, grapes will be removed. Then what is remaining? Only cherry and melon will be there. Let's see what is the output that we get. You see, cherry and melon will be there because the first row values and first column values has been removed. So this is a way you can remove the rows and columns. And how to check an element is existed or not? So to check the element, we have the modulus in modulus. So let's take apple. The element, that is apple, is available in matrix 1 or not. Then you have to use modulus in modulus operator. Modulus in modulus, and give the matrix 1. Is it available? Yes, it is available in matrix 1. Suppose I give another one, grapes. Suppose I give grapes, then use the operator modulus in modulus and the matrix 1. Is it available? No, it is not available. You are getting the output as false. So this is the way you can check whether an element is available or not in the matrix by using the modulus in modulus operator. And you need to find out the number of rows and number of columns by using the dimension function. So dimensional of matrix 1, 2 rows and 2 columns. For example, dimensions of matrix 4. Dimensions of matrix 4, 3 rows and 2 columns. And the dimensions of matrix 2. Do we have matrix 2? Let's see. No, matrix 2 is not yet created. And the dimensions of matrix 3. Yes, 2 rows and 3 columns. So you can find out the number of rows and number of columns by using the dimension matrix. And also we can find out the number of elements is available in the matrix by using the length function. Give length of matrix. Total number of elements is available in matrix 1 is 4. So let's find out the number of elements available in matrix 4. So the number of elements available in matrix 4 is 6. So this is a way you can find out the length. So let's combine two matrices. Yes, so to combine two matrices, let's go matrix 5. Matrix 5. So to combine two matrices, you have to use the C bind function or R bind function. Two functions that you can use. For example, what is the functionality of R bind function? It is going to add the values as a rows. And C bind function, it is going to add the values as a columns. So before that, what we will do is, we will create one more matrix, that is matrix 2. To understand clearly, suppose I am creating matrix 2 by using the matrix function. So here also I want to give the values, fruits values. For example, apple, banana, guava, cherry. So next one is melon. And the next one is kiwi. And the next one is grapes. The next one is orange. And the number of rows is 2, comma number of columns is equals to 2. Yes, matrix 2 is created. Let's print matrix 2 values. Yes, let me clear this console to understand. 1 second. Let's execute matrix 1. Sorry. So this is matrix 1 values and this is matrix 2 values. Right? Let's combine these two matrices. So let's combine these two matrices and matrix underscore combination. The matrix name is matrix underscore combination. And you have to add it as a rows. So the first parameter is matrix 1 and the second parameter is matrix 2. And let's execute the matrix combination matrix underscore comb. See here, it has been added as a rows. Suppose here I give C bind. What happens? Let's see. C bind I am giving. Let's observe the output of previous one and this one. See here, it has been added as a columns. Apple, banana, guava, cherry and melon, kiwi, and the right side it is getting grapes and orange. Okay. Means when you are using the C bind function, it is adding as a columns. When you are adding as a rows, when you are giving a R bind function, it is adding as a rows. This is a way you can combine the matrices. And let's create some special matrices. The first one is suppose if you want to fill all the values, row values and column values with a single constant value, then you have to use the matrix function. Let's see the matrix function, and here I am giving 5 is the constant value. The number of rows is 2 and number of columns is 3. See here, all the values filled with 5. The number of rows is 2 and number of columns is 3. So this is a way you can create the matrix. Suppose the next one is, if you want to create a diagonal matrix. So to create a diagonal matrix, what you have to do is you have to give the diagonal function. So within the diagonal function, suppose all the diagonal values is 5 and number of rows is 3 and number of columns is 3. See here. So the all the diagonal values is only 5 and the remaining values are 0, and it is going to have 3 rows and 3 columns. The second parameter is representing that the number of rows, and the third parameter is representing that the number of columns. So this is a way you can create a diagonal matrix. And finally the identical matrix. What is meant by an identical matrix? All the diagonal element values as 0. All the diagonal elements values is 1, remaining all values is 0. Then it is called as a diagonal matrix. So this is the way you can create a diagonal matrix. So these are the different special matrices that we can create. So this is about the matrices, and I hope it is clear to you. So thank you everyone.